Dear students, today we will see the priority scheduling algorithm with respect to preemptive cases. So what is preemptive cases? We know that preemptive means whenever a process is given a CPU and higher priority process comes, then process which is running in CPU will be preempted out of the CPU and the highest priority process will be given a CPU for the execution process. So let us understand this with an example. Before getting into an example, we, as I told in previous class also, the low value high priority. Low value high priority means the lowest the value of priority, the highest is its priority. For example, see this column here. I have priorities 5, 4, 2, 0 for different processes. Now 0 for us will be the highest priority and 5 will be the lowest priority. I repeat, 0 is highest priority and 5 is the lowest priority. That is the reason behind low value high priority statement. I hope you understood it. Let us see how exactly the priority scheduling algorithm in preemptive cases works. So here we can see there are 4 processes, P0, P1, P2, P3. Their arrival times are 0, 1, 3 and 5 milliseconds, and their burst times are 10 milliseconds for P0, 6 milliseconds for P1 and 2 milliseconds for P2 and 4 milliseconds for P3. Now respective priorities are 5, 4, 2, 0. And let us not concentrate on these 2 columns right now. After drawing Gantt charts, we will come back and see what they are. Waiting time and turnaround time. So here in this particular case we have 4 processes, as I told, P0, P1, P2, P3. Now here we can see the arrival times. So arrival time of P0 is 0 millisecond. So it has been given a CPU, that is 0 for P0. It starts its execution. Now when it comes to 1 millisecond, P1 has arrived, and earlier we are not seeing the priority column. The reason is when P0 arrived, no other process has arrived in the system. Now we have the option. So when we check that priority of P1 is more than the priority of P0, that is 4 is the highest priority than the 5. So P1 has been given a CPU for the execution, and that means P0 has been preempted out of the CPU. P1 has been preempted in. So P1 started execution, then at 3rd millisecond P2 has arrived. 3rd millisecond P2 has arrived, and we can see again here. So when we see the priority column, P2 is of highest priority than P0 and P1. So 2 has been allowed to execute its instructions, and P2 takes 2 milliseconds and it completed. So here P1 has been preempted out. And later P3 arrived at 5 milliseconds. By that time P2 has already completed its work. So P3 has been given a CPU as the priority of P3 is highest than the others. Now we have completed P2 and P3. Now left out is P0 and P1. We have to choose which one should be given a CPU now. So when we check priority, the P1 is having the highest priority is given a chance, so P1 will be given a chance. And we know that P1 has already executed for 2 milliseconds. That means 6 minus 2 is 4 milliseconds. So here it executes for 4 milliseconds. That is 9 plus 4 is 13 milliseconds. Now later we don't have option. P0 is given a chance and it will complete. So even here also we know that P0 has already completed 1 millisecond. That means 10 minus 1 is 9 milliseconds. So that's why 13 plus 9 is 22 milliseconds. So the total time taken by the all processes to complete is 22 milliseconds. Now let us concentrate on this column, that is waiting time. What is waiting time? Waiting time is, here we can see P0. When it has started, the last swap of P0 is 13. Now 13, P0 has already completed some part of its earlier, so CPU has been given to it. That is what we call it as That's why 13 minus 1, then the arrival time, that is minus 0, is my waiting time. I repeat, 13 minus 1, arrival time minus 0 is 12 millisecond. Now P0 is waiting time, P1's last slot is 9 millisecond. Now 9 minus 2, because it has already executed for 2 milliseconds between 1 to 3. So 9 minus 2 and its arrival time is 1. That is 9 minus 2 minus 1 is 6 milliseconds. Now P2, whenever it has arrived, we have given CPU to it and it has not waited for anything. So waiting time is 0. Same case with P3, whenever it has arrived, it has been given a CPU and it completes its execution. So that's why 0. So we all know the average waiting time will be 12 plus 6 plus 0 plus 0 divided by 4, that is equal to 18 divided by 4. So the 4 is these 4 processes, that is 4.5 millisecond. So this is what is average waiting time, and turnaround time is waiting time plus the burst time. See here, waiting time of P0 is 12, burst time is 10, that is 22. Waiting time of P1 is 6 and burst time is 6, that is 12. So waiting time of P2 is 0 and the burst time is 2, 0 plus 2 is 2 millisecond, and the waiting time of P3 is 0 plus 4, which is 4 millisecond. So the average turnaround time is 22 plus 12 plus 2 plus 4, that is 40 divided by 4. Again 4 is nothing but the number of processes in a system. So that is 10 milliseconds. So the turnaround time is nothing but the total time a process has waited since its inception in a system. I hope the concept is clear here. Thank you for watching.